Wow, nice. I'm going to look back and see if that worked. Understanding whole numbers, integers, and rational numbers. This is a combination of 4-6 and mostly 5-1 in your textbook. So this is the first section of the new unit. So, yes. So we have a Venn diagram, and my name is... Today my name is Sophia. It's true, because we had a test. All right. Now, as I'm reading this, you should be following along and not dozing off like I'm reading you a bedtime story. Okay? Follow along as I read. Before we use the Venn diagram, we need to know how it works. In a Venn diagram, there are circles or ovals that overlap. The overlapping areas show what is a common to both groups. In the last chapter, we talked about factors. So here's an example of how a Venn diagram works. So we have factors on the left circle. So that would be this guy. In the green circle, we have factors of 24. Going from bottom to top, it's 1, 2, 3, 4, 6, 8, 12, and 24. In the other circle, we have a bad circle. In the other oval, there we go. We have factors of 36. There's a lot more because it's a bigger number and also it's even. We have, so it's bigger number, so it's going to be more. And since it's even, there's even going to be more. We have the factors that are 1, 2, 3, 4, 6, 9, 12, 18, and 36. We should put numbers that are in both, so you can see, actually, we'll get to that. But where would we put numbers that are not factors of 24 or 36, such as 7? Let's say you had to put the 7 somewhere. Where would you put it? Raise your hand. Where would it go? Where would a 7 go? Yes. In the middle? Like here? You sure about that? You have to put a 7 down. Is 7 a factor of 24? No.
Oh, no, it's not. Just kidding.
You're thinking of 21. Yes. You're going to put it outside. Exactly. So I'm going to put that 7 right there, and that is really thick. Because I'm telling you, you have to put a 7 down. Where would you put it? You would put it outside the circle.
Why do you have to? Like, why would you have to?
Because imagine you're walking into a room, and you have to bring, or you're going to a party, and you have to bring something. All right, some food. Okay, you're going to a party, you have to bring food. It's like a potluck. Okay, and you have this food, and you come walking into the room where you put all the food, and there's a specific table that's for dip. There's a specific table that's for crock pots, and here you are holding a salad. And you're like, it can't go on the dip table. It can't go on the salad table, so I'm just going to go put it over here. Okay? If you had a word bank or a letter bank, such as down here, and you had to put all the numbers somewhere. Okay? That's what I meant by that. Let's find out. It says here, what is special about the numbers in the overlapping area? What's so special about them, Jamichael? Yes, they are common factors. They are common factors. Okay, reading along again. Here's another example. Let's fill this one in together. Yay! We want to show the relationship between certain classifications of dogs. The terms we need to organize are as follows: toy poodles, poodles, standard poodles, Siamese cats, and dogs.
Are those cats with no hair?
Now, right off the bat, what did you notice about these dogs? Yeah. One of them's a cat, so where should it go in this diagram before we even do anything? Yes. All right, let's put an end to this. Quiet. Let's see here. Okay, Google, Siamese cats. There, that's a Siamese cat. Thank you. So we put Siamese cats on the outside because that's either one really ugly dog that's confused or it's actually a cat. Now, if we want to talk about the very... Yes. I don't know. No, that's a completely different continent. If I want to do something that's super specific, okay? If I want to do something that's super specific, that's going to go on the inside of this circle, and inside of the other circle, and inside of the other circle. This is actually a Venn diagram. But to show you exactly how it's a Venn diagram, see how these guys are, that's a Venn diagram that you've been seeing for years, right? It's just this, like that. Okay, that's what the circle is. Okay? There. Yes, it's... Thank you. Okay. So what's the most specific? If we have a list of things where we have to go toy poodles, poodles, standard poodles, Siamese cats, and dogs. We've already taken care of dogs or Siamese cats, so I can click that. What's the most specific type of something in there, Joe? Toy poodles. So we're going to write toy poodles. It's okay. That's an opinion. You can like them or not. But just don't try to get other people to believe an opinion of stuff that you like and don't like, especially something so distant from yourself as the type of dog. It's okay if you don't like that kind of dog. It's okay if you do love that type of dog, but it has nothing to do with getting somebody else to believe how you believe with that. Yes? It's a good question. It's actually the smallest type of poodle. Okay, then we have standard poodles. That's also the other. Standard poodles are actually, I think, they might be the smartest canine breed, if I'm not mistaken. It's not. I'm not talking opinion. I'm talking studies. Next one we have. What is the next? So we've taken care of this. Toy poodles, standard poodles. We have poodles and dogs left. What is the next classification general? Yeah.
Is it poodles?
Yep, it's going to be poodles. And if we have time after, or I'll put, as you guys are leaving today, I'll put up a picture of the difference between the two of them. And what do we have next, Jermichael? Yes, dogs. You see how all of these on the inside in the pink circle, all of those are poodles. Do you agree? Yeah. Oops. So the Venn diagram, all those are poodles. Now, everything in the orange are dogs, because dogs is the outside, okay, and every poodle is a dog, and every standard poodle is a poodle dog. Aiden's answering service. Hi. Wonderful. Is it going to be this time every day, or is it going to fluctuate a little bit? Okay, you don't need to call anymore. All right, thank you. Peace out, brah. So we have that all poodles are dogs. We have that all toy poodles are poodles that are dogs. And we have that all Siamese cats aren't dogs, they're not poodles, they're not toy poodles, and they're definitely not standard poodles. Okay? We are getting it. What does it mean when a group is completely inside another oval? Yes.
That they're
Yes, that's exactly it. It is a more specific classification. More specific classification. More specific classification. Am I recording?
Yeah.
Okay. It is more specific classification.
From Hotel Transylvania.
Now, in this chapter, we are going to be talking about whole numbers, integers, and rational numbers. Before we can compare them, you must understand that each of them is, or what each of them is individually. All three are names of different, focus. All three are names of a different group or set of numbers. Here we have definition of whole numbers, integers, rational numbers, and irrational numbers. I'm going to read these, and then you're going to take 4 minutes. 4 minutes, yeah, to copy those down. So we have whole numbers in this set, so don't copy them down yet. Listen, then write. In this set includes 0, 1, 2, 3, etc. It also includes any number that can be written as a whole number, such as 5 over 5, which is just 1, and also 9 over 1, which is, everyone? 9. Beautiful. Integers. This is what fun we had in the first chapter, or the first test we had. Set includes -2, -1, 1, 0, or 0, 1, 2, up to infinity, and then in the other direction, negative infinity. Then we have rational numbers. This is a set that includes common fractions such as 1/4. It also includes mixed numbers, decimals, integers, and whole numbers because all these numbers can be written in the form of A over B. In this here I have form A over B, but I want you to write it like this. Oops. I want you to write it like this. A over B. Then we have irrational numbers. These are the kind of numbers that when they get into an argument, they let their emotions get the best of them and they throw things.
So they're irrational.
Get it? Irrational. This set includes numbers that cannot be represented as a fraction, as in goes on forever, such as pi, the square root of 3, and 0.24682, blah, 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 blah. So this is square root of 3. You don't have to write that. And this is pi. You don't have to write that. So please take some time to write that. I'm going to start a timer. So if anybody's watching this on YouTube, you can skip forward to when that timer gets to 0. Let's see here. Yeah.
Why do you only give us so much time?
Because we have class to do. Okay, how about you write and stop worrying about what I'm doing? And also, for those of you that have you did your homework, it's also, all of them are on that piece of paper that I had you keep out on your desk. Did I type something wrong? Mm. Oh, it's not. Time up. Okay. Understanding whole numbers, integers, and rational numbers. Continuing the method with the Venn diagram. In the method, or we're going to skip that and go back to that question, actually. No, we're going to go back to it. Because I want us to practice with it before we answer that question. Label each circle appropriately, using the terms whole numbers, integers, rational numbers, irrational, and rational numbers / irrational numbers. Then use the same number bank below to the diagram. Then use the. That's why. Then use the number bank below the diagram to place the numbers in the correct category. I don't know. One of us did. Use the number bank below the diagram to place numbers in the correct category. Give one example of a number that will fall outside of all the numbers. Give one example. Oh, okay. So we have that number bank down below, and we have to put all of them somewhere. We have to put all of them somewhere. Now I'm going to find the most specific classification, which is whole numbers. Whole numbers. Can someone please tell me a whole number from that number bank? Yes, Lexi. What is it? 6. I agree. Yep. -7. I disagree. Yes. 11. Yes. Yes, Jack? 5/1. So as we're doing these, I want you guys to circle them, because we've done 6, we've done... Oh, it's not 11, it's 11.0. 11.0. Is 5.1 there? No, okay. So it's not there. What else? ¿Qué más tenemos? What else do we have? Yes? 15/3, yep, because that's just a funky way of saying 5. Yep. 17/7 is not a whole number.
No, because that's not that. That's like 2.4.
That was a bad one.
It's like 2.5. No, 2.5.
Mm-hmm. Yes? 9,317. I did that in a southern accent earlier, too. I don't know why. We got this one, too. Good. Is there any more? Anybody who hasn't been carrying the class thus far? Amanda. Or Megan, sorry, Megan. It sure would, because that's just 11. Beautiful. Next, we're going to go one more out, and we're going to go with integers. Integers. Now, I'm going to look at the definition of an integer, so I don't mess this up. This set includes -2, -1, 1, 0, 1, and 2. Notice that all whole numbers are included within the set of numbers. Cole. -2. You are correct. What color should I use, Cole?
Green.
What color green, Cole?
Yeah.
Let's see if this shows up. So we have, what is it, -2? Can you see that okay?
Yeah.
Okay.
Negative 5
Negative 5
over 5.
over 5, exactly, because that's just negative 1. Joe?
Negative 7.0.
Negative 7.0. That's just 7. Good. What else we got? Yep. Negative 204. Abby? Negative 1/4. Negative. No. I mean to say no. Nope. Incorrect. I apologize, but you are incorrect. Yeah. Joe. We forgot a whole number.
Oh, wait, no, we didn't.
Okay.
Wait, what's the twos?
This thing?
No. Oh, yeah, what's the
Huh.
It's like a
Weird. We'll get to that. We'll get to that. All right, that is all the negative numbers. Now, we go out further, and we're going to be picking on rational numbers. Ooh, stop it. Rational numbers. Trying to get them.
Negative 1/4.
Negative 1/4. What color should we use?
Blue.
What color blue?
Like a mint blue.
Like a mint blue.
Mint blue. Cyan. Yeah, that.
Okay. So what did you say? Negative 1/4 is correct. Okay. So I'm going to circle negative 1/4 on the bottom. Is that it? Yeah. Yeah.
Would 3.5 be fine?
Yep. 3.5. So remember, rational numbers are set includes fractions such as 1/4. It also includes mixed numbers, decimals, integers, and whole numbers because all of them can be written as a fraction. Hi. Go ahead and put it right on my desk, please. Okay? I'm going to go with Caitlin again because she hasn't helped as much as you guys. What you got? 0.3. That is correct. Mandy, what else you got?
17 over 7.
17 over 7 is correct. Joe, what else you got?
0.88.
0.88 is also correct because that's 8800ths can be written as a fraction.
Wait.
Maggie, do you know anything? Look, let's rephrase that question. Maggie, can you give me another one? 0.12345. These little dots here mean it goes on forever. Yep. Did we? Did we do it? We got that one already. Okay, that was a trick question. Maggie, I'm sorry, I didn't realize that we were done with that. Those are all the rational numbers that are in there. So, we have... We are going to put those out here with the irrational numbers. These are the numbers that are so irrational we can't even have them in our circle of friends in this situation.
You know what? I say we both want.
No, they're not. Whoa. What did I just do? What did I just... Oh, wow.
There's so many.
There they are. So, irrational... What?
Push the button.
Numbers. The irrational numbers are all the other ones that we didn't do yet. Yes, have a good time. Win, win, win. Yes.
I'll just do them on the computer.
Is that? I didn't give you notes on your desk? Write all the rest of the numbers there. I still didn't hear anything about football. Where's your game?
Highland.
Not you. You. Alton. Okay, if you're for some reason mistaken, come back. I gave you all the baseball players as homework just now, by the way.
They said it'd be a
Oh, okay. No, here. There we go. Okay, lots of student athletes in this class. All right. Irrational numbers. And I lost my stuff. I put down my notes. So we have 5.2 with a line over it. What that means is, yeah, we'll keep it black. 5.2 with a line over it. What that means is it continues. It goes 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, 5.2, forever. Okay? Next we have 0.1, 2, 3, 4, 5, etc. Those lines mean it keeps going. We're not going to even write anymore. It just keeps going. Yes, ma'am.
Why wouldn't that be under the rational number whenever 0.88 is? Yeah.
Where 0.88 is, which one?
The rational numbers.
Are you talking about why isn't this one there?
Yeah.
Because we can't represent, how are you going to represent that as a fraction? Whereas 88 hundredths is this. Okay? You can't, we don't know because it goes like this, which means, yeah, that keeps going. Okay? Yes? What? Right, but that wouldn't be 0.1. Next we have the square root of 2. What a square root is, that is, for example, the square root of 4 is 2, because 2 times 2 is 4. The square root of 16 is 4, because 4 times 4 is 2. So this is the opposite of this. These guys are opposites of each other. 2 times 2 is 4. 4 times 4 is 16. Yes. Has? Oh, heartbeat. Got it. Sure. So those are the way that this works. Now let's go back up here. In the Venn diagram below, what does it mean that each grouping fits completely inside the other? What does it mean that each group fits completely inside the other? So I'll tell you. The inside circles, meet the characteristics of the other circles, or the outside circles. Meets the characteristics of the outside circles. So that means that whole numbers are rational numbers. Whole numbers are integers. But integers are not necessarily whole numbers. It's in there, but not every one. Yes?
I don't know what maybe is, but
Okay. The inside circles meet the characteristics of the outside circles. Here's an example that I did a couple class periods ago. I'll do this again. It meets the characteristics of the outside circles. All right. There is, okay, who wants to be, their name to be, okay. Let's go Summer. Summer's a new student. Everyone meet Summer. Hi, Summer. Okay.
Hi, Summer.
So, we have Summer. Would you agree that Summer is a girl? Yes. Okay. Would you agree that Summer is a girl in Smith's 7th period? Okay. Would you agree that first person I saw, Nope, you don't need to write this down. Would you agree that Joey is in Smith's 7th grade?
Yeah. He still goes to
I can put all of you in here, but I can't put all of you in here. Okay? All the girls in the class could be in the center circle. Okay? So we could put 7th grader. Anybody who is not in this classroom could be a 7th grader. Okay, let's do who. Is there a 7th grader that does? Who's your best friend? How does Laheen spell his name? Is this a real person? Okay, fine, whatever, as long as it's not making fun of him. So we have Laheen, who's a 7th grader. Okay, 7th grader, he fits that, but he's not in my 7th period, and he's not a girl. But Summer matches all of these, and that's how that works. That's what the Venn diagram looks like. So if I wanted to take some of these out, all these are true, but Joey gets kicked out of that inner circle because you're not a girl. Yeah, that's so insulting. Finally, moving on to this. Somebody served under the net? It is preferred that we write the numbers in simplest form. I'm on the next page. Why keep things more complicated than they have to be? Below are some examples of how we write numbers in simpler forms. This is stuff that you already pretty much know. 23.40, unless we're talking about money, bling bling, we write it as 23.4. You don't need extra zeros at the end if it's not necessary. Then we have 23.04. This time, the 0 is a placeholder, so we need it. We cannot simplify it further. 5.0, I'm going to go ahead and, whoops. There. 5.0, the 0 doesn't have any function, so we drop it and write it as just 5, unless you're talking about a Mustang. Then we have 2/18. We can divide both the top and the bottom by 2, so we can rewrite it as 1.9. We had that this last test yesterday. 32/8, improper fraction, so we make it simplest form, 4. Then we have 31/8. That cannot be going evenly, but it is 3 7/8, so we write it like that. Then we have 15 13/3. That can be simplified to 29 1/3. Okay, homework practice. We have to tell whether a number is a whole number, an integer, a rational number, or nothing. For example, here are some answers that you could have that would be a whole number, integer, and a rational number. We could have 23, we could have 1, we could have 22, we could have 2,400. No, I'm going to do my birth or my graduation year. We could have 2002 if we wanted to. Okay? I know that you guys are. No, I graduated high school too. So we have to figure this. This is exactly like the homework. There are actually some people who almost finished the homework in the 5 minutes that they had to work on the homework. So we have 72.0. 72.0. Is that its simplest form? No. We can simplify it to just 72. Okay. Now we would go back and look at our definitions of a whole number, a whole number, an integer, and a rational number to see if it is those. Is 72 a whole number? Yes. You betcha. Is it a integer? Yes. You betcha. Ew. There. Then is it a rational number? Yes, it is. Okay? Yes, it is. If you're having something in the in circle of that diagram that we did, you know that it's going to have the IR. Then we have 9 firsts. 9 firsts, is that a rational number? Taylor? Owens? What is it? Whole number. Yes, it is a whole number. But what is the simplest form of that? 9. So we know that it's also going to be an integer, and we know it's also going to be rational. Next we have 912 and 7,000. We'll go 7 thousandths. 7 thousandths. Is it in simplest form? Yes, it is. Okay, is it a whole number? No. It's got 7 thousandths there. Is it an integer? No. Can you write it as a fraction? Actually, you can. You can write it as a fraction, which means it's rational. You don't have to write this, but this is how that would be. You have 912 and 7 thousandths. 7 thousandths. Okay? So, it is simplified. Good. Next, we have 17 over 5. Is that its simplest form? No, it is not. Because you can do 3 2/5. And that is a rational number. Then we have this number here. It means it goes on and on we go. So you know that is, okay, we cannot, it's irrational. So it's not necessarily simplified, but it looks a lot like this thing. Okay, you can write the pi symbol. And this is a irrational number. Now notice how I have IR without a comma between it. Yep. Irrational. Okay. Next, I'm going to zip through these so you guys can be. Okay. This one will be. Yeah, I'm going to zip through these and explain myself as we go. So you have all these examples. The simplest form, it's already simplified. Then it is not a whole number because there's a negative there. It is an integer because it's negative 400. It is a rational number as well. We have negative 9 90ths, which simplifies by dividing everything by 9, and we have negative 1/10. And that is not an integer. It's not a whole number, but it is quite rational. 11 twelfths, that's already simplified. It's not a whole number because it's missing a 12th. It's not an integer because it's not a whole number. Or it's not an integer because it's not a whole number that's positive or negative. But it is a rational number because we can represent it as a fraction. We have the square root of 3, which is actually 3, square root, that long thing, 1.732508075688772. No, I'm done. Okay, it's already simplified. It is a IR, irrational, no comma. Then we have 45 divided by 9 can be simplified by just saying 5. And that is a whir. Whir. W-I-R. Like that. Caught myself. There you go. Bye.